Hi, I'm Adam Porter, and this is Programming Mobile Applications for Android Handheld Systems.
Today I'm going to introduce you to the Android platform. I'll start by giving you an overview of the Android platform and the components that make it up. And then I'll present each of these components and discuss how they help developers build great mobile applications. So let's get started. The Android platform is a software stack, and it was designed primarily, but not exclusively, to support mobile devices such as phones and tablets. And this stack has several layers, going all the way from low-level operating system services that manage the device itself up to sample applications, things like the phone dialer, the context database, and a web browser. Android also comes with a Software Developers Kit, or SDK, which is used to create Android applications. And finally, there's tons of documentation, tutorials, blogs, and examples that you can use to improve your own understanding of Android. And I encourage you to take advantage of all of these resources. Now this graphic represents the Android software stack. And as you can see, it's organized into several layers. At the bottom, there's the Linux kernel layer. Above that, there are system libraries and the Android runtime system. Above that, there's a rich application framework layer to support the development of new applications. And at the very top, Android provides some standard applications. Again, things like the phone dialer, the web browser, and the contacts database. So let's look at each of these layers in detail, starting with the Linux kernel layer. The Linux kernel layer is the lowest layer of software in the Android platform. This layer provides the core services that any Android computing device will rely on. Android's Linux kernel, just like any Linux kernel, provides generic operating system services. For example, it provides a permissions architecture so that you can restrict access to data and resources to only those processes that have the proper authorizations. It supports memory and process management so that multiple processes can run simultaneously without interfering with each other. It handles low-level details of file and network I/O. And it also allows device drivers to be plugged in so that Android can communicate with a wide range of low-level hardware components that are often coupled to computing devices, things like memory and radios and cameras. In addition to the common services supported by any Linux kernel, Android's Linux kernel also includes several Android-specific components. For example, Android's Linux kernel includes its own power management services, because mobile devices often run on battery power. It provides its own memory sharing and memory management features, because mobile devices often have limited memory. And Android's Linux kernel also includes its own inter-process communication mechanism called the binder, which allows multiple processes to share data and services in sophisticated ways. And of course, this is just a few of the Android-specific features. There are many others as well. The next layer up includes a variety of system libraries. These libraries are typically written in C and C++, and for that reason they're often referred to as the native libraries. And these native libraries handle a lot of the core performance-sensitive activities on your device, things like quickly rendering web pages and updating the display. And for example, Android has its own System C library, which implements the standard OS system calls, which do things like process and thread creation, mathematical computations, memory allocation, and much more. There's the Surface Manager for updating the display, a media framework for playing back audio and video files, WebKit for rendering and displaying web pages, OpenGL for high-performance graphics, and SQLite for managing in-memory relational databases. In addition to the system libraries, this layer also includes the Android runtime, which supports writing and running Android applications. And there are two components in the Android runtime that we'll talk about today: the core Java libraries and the Dalvik virtual machine. Let's talk about each of those one at a time. Now first, Android applications are typically written in the Java programming language. And to make it easier to write applications, Android provides a number of reusable Java building blocks. For instance, the Java and JavaX or Java extensions packages include basic software for things like common data structures, concurrency mechanisms, and file I/O. The Android packages have software that's specific to the lifecycle of mobile applications. The org packages support various internet or web operations, and the JUnit packages support the unit testing of applications. The second part of the Android runtime is the Dalvik virtual machine. The Dalvik virtual machine is the software that actually executes Android applications. Now, as I just told you, Android applications are typically written in Java. So you might have assumed that since they're written in Java, they would probably run on a standard Java virtual machine. But in fact, that's not the case. What typically happens is that developers first write their applications in the Java programming language. Then a Java compiler will compile the Java source code files into multiple Java bytecode files. Next, a tool called DX transforms the Java bytecodes into a single file of a different bytecode format called DEX. And this bytecode file is usually called classes.dex. Next, the DEX file is packaged with other application resources and installed on the device. And finally, when the user launches the application, the Dalvik virtual machine will then execute the classes.dex file. Now, the reason for doing all this is that the Dalvik virtual machine, unlike the Java virtual machine, was specifically designed to run in the resource-constrained environment, which is typical of mobile devices. Now, when I say resource-constrained, what I mean is that compared to a typical desktop device, the typical mobile device is less powerful and more limited in many ways. For example, it will probably have a slower CPU, less memory, and a limited battery life. So if you're interested in finding out more about the Dalvik virtual machine itself, then I recommend you take a look at this video, Dalvik VM Internals by Dan Bornstein of Google. The next layer in the Android software stack is the application framework. The application framework contains reusable software that many mobile applications are likely to need. For example, as we'll see in a minute, the view system contains common graphical elements, things like buttons and icons, that many applications include in their user interfaces. Let's take a deeper look at some of these components. One application framework component is the package manager. The package manager is essentially a database that keeps track of all the applications currently installed on your device. So here's the home screen of my phone. When I click on the launcher icon, the phone shows me a bunch of icons, each one representing an application package that's stored on my phone. The package manager stores information about these applications, and that's useful for several reasons. For example, it allows applications to find and contact each other so that one application can share data with another application, or so that one application can request services from another. Another application framework component is the window manager. The window manager, as the name suggests, manages the many windows that comprise applications. Here I'm launching the browser application, which appears as two windows. At the top, there's the system notification bar, which displays various status indicators that tell the user about things like Wi-Fi signal strength, remaining battery power, and the current time. There's also a main application window that in this case is showing the current web page. An application can also use various sub-windows, such as when it shows menus or dialogues. As I mentioned earlier, the application framework also contains the view system. The view system contains many common graphical user interface elements, such as icons, text entry boxes, buttons, and much more. Let's take a look at the phone application. As you can see, the phone application's top-level user interface is organized as a set of tabs. and each tab corresponds to a different user interface that supports a different set of tasks. The Phone tab shows me a phone dialer. The Call Log tab shows a list of recent incoming and outgoing calls. And the Contacts tab shows a list of stored contacts. Now, as I just said, when I select the Phone tab, I'm shown a user interface that mimics a phone keypad. That keypad is made up of view system components, things like buttons and text views. And the application will listen as I press these buttons and then respond by writing the corresponding digits to a text view to show me what number I'm dialing. The next application framework component is the Resource Manager. This component manages the non-compiled resources that make up an application, things like strings, graphics, and user interface layout files. Now, to give you an example of non-compiled resources, let's go back to the Phone application again. Now, this tab has some English words on it. And that's fine because I speak English. But Android is available around the world. It's not limited to English speakers, and so it's important that we have an easy way to customize applications for other languages. And one way that Android supports that is that it lets you define strings in multiple languages. For example, the Phone application has a string file for Italian words as well as one for English words. So if you speak Italian, then you can go into the Settings application and select Italian as your default language. Now, if I go back and rerun the Phone application, you'll see that Android will use the appropriate Italian words rather than the English words. And of course, you can do this for as many languages as makes sense for your application. Another application framework component is the Activity Manager. Now, at a high level, Android activities often correspond to a single user interface screen. Applications are then created by stringing together multiple activities through which the user can navigate. The Activity Manager helps to coordinate and support that kind of navigation. So suppose I want to listen to some music. So here I'll click on the launcher icon to show my applications. From there, I can click on the music player icon, and that will start an activity that brings up a user interface screen showing the music I have on my device, in this case sorted by artist. I can select an artist and see the albums by that artist. I can select one album by clicking on it, and this starts another activity that brings up another user interface screen showing the songs in the album I just selected. Now if I hit the back button, I can go back to the last activity, and for example, I can choose a different album. Now I can click on a specific song in that album, and yet another activity starts up that brings up yet another user interface screen, allowing me to play this song. Another application framework component implements content providers. Content providers are essentially databases that allow applications to store and share structured information. For example, here we see that the Phone application can access stored contact information and use it to dial a phone number. And it can do that because the contact information is stored in a content provider. And even better, content providers are designed to work across applications. So not only can the phone dialer use the contact information, but so can the MMS messaging application, and so can various social media applications. Let's take a look. So going back to the Phone application, I can select the Contact tab to access stored contact information. I can select one of the contacts to quickly dial that contact. Now, as I said, I can do that because contact information is stored in a content provider. And again, even better, content providers are designed to work across applications, so not only can the phone dialer use the contacts, but so can the MMS messaging application, and so can Twitter, Facebook, my email readers, and things like that. The next application framework component is the Location Manager. The Location Manager allows applications to receive location and movement information, such as that generated by the GPS system. And this allows applications to perform context-specific tasks, things like finding directions from the current location. Now here I'm calling up the Google Maps application, which queries the Location Manager for my current location, and then shows a map of the area around that current location. The last application framework component I'll talk about today is the Notification Manager. The Notification Manager allows applications to place information in the notification bar. For example, to let users know that certain events have occurred. For example, suppose I want to send my wife an MMS message. And let's suppose that right at this minute, she's writing an email or making a phone call or whatever. So although she probably wants to know that I've sent her an MMS message, she might not want that to disrupt her right now. Well, Android handles this with a Notification Manager. And the way that works is that there's some software running on her phone that's always listening for incoming MMS messages. When one arrives, that software uses the Notification Manager to place an icon in her phone's notification bar. And that's shown here as a little smiley face icon. And I've whited out some of the information there for privacy. Now when she's ready, she can pull down on the notification bar, which then shows more information about the specific notification. And if she clicks on that notification, the MMS application will start up, and she can read and hopefully respond to my message. The last layer of the Android software stack is the application layer. As I said earlier, Android comes with some built-in applications. And these include things like the home screen, the phone dialer, the web browser, an email reader, and more. And one of the things that's really nice about Android is that none of these apps is hard-coded into the system. If you have a better app, you can substitute your app for any of these standard apps. So that's all for the Android platform. Please join me next time when we'll explore the Android development environment. See you then.